So we've talked a lot about this idea of finding the gradient function and differentiating, and I'm now wanting, or at a stage where I want to go through precisely how we get there and to understand the mechanics behind the scenes, and we call it differentiation from first principles, okay? Because we're going from, these are the initial moves that make and allow differentiation to work, okay? So what I've got here is part of a curve, okay? I'm going to use this as a way of demonstrating how this works. So let's say I have a point on this curve, and I'm going to label this point so that it has an x value, okay? So let's say that this is x, and it has a y coordinate of f of x, okay? Because the function is y equals f of x, I can find the y coordinate by substituting it into f, okay? So this coordinate is x f of x, okay? And let's say what I want to do is I want to find the gradient of the curve at that point. Now, from what we've learnt, okay, about tangents previously, I could just draw a tangent, okay, and estimate the gradient of the curve. But what I really want to be able to do is do something a little bit more careful. And I want to be able to find the exact value of that gradient. And just drawing a line isn't going to cut it. So what I do is I look at another point that's reasonably close by. Imagine that I've zoomed in on my graph here, okay? So that this is close. And let's say that this is h further along the curve. Okay, so this has now x coordinate, x plus h. So that this distance is h. Okay? Now, if the x coordinate is x plus h, then the y coordinate of that point must be f of x plus h. Okay? And what I'm going to do is I'm going to estimate the gradient of the curve at that point by looking at the gradient of the chord between these 2 points. Okay? Now, you'll notice that that gradient isn't going to be precisely the same as that one. Okay? So, they're not the same. It's just an estimate of the gradient at that point. Now, if I wanted to find the gradient of that chord, then I could think of finding the difference in the y coordinates divided by the difference in the x coordinates. So we know that the difference in the x coordinates is x plus h take away x, which is just the h. The difference in the y coordinates will be f of x plus h. So the y coordinate of that point, take away the y coordinate of that point, which is f of x. Okay, so we can say that the gradient of the chord, let's call it m for the time being, is the difference in the y coordinates divided by the difference in the x coordinates, which is f of x plus h take away f of x all over h. Now, that's all well and good. Okay, so I'm going to have an estimate for the gradient, but this point is quite far away at the moment. Okay, although I'm saying that h is a small distance, in the grand scheme of things, it's quite far away. So what I want to do is I want to think about bringing that point closer to this one, so dragging it along the curve. Now, the effect that that will have, if I draw on some new chords, So you see the effect that it will have is that the gradient of the chords that I look at will get closer and closer and closer to the tangent at that point, the one that I'm interested in. So what happens is that as I drag that point along, the gap between x and x plus h shortens, and h gets smaller and smaller and smaller. So what would happen if h tended towards 0? What would happen is that my gradient would get as close to the one that I want as is reasonably possible. So we say that the gradient of the curve at that point, dy by dx, is this, but we're letting h tend towards 0. So we're letting h get smaller and smaller and smaller. Okay, so the gradient function is given by this limit definition. And this is what you must know going forward, okay? This is differentiation from first principles. We will see how it works in the next few videos as we practice using it. But this is where it comes from. This allows you to find the gradient function using a limit definition, and all those like little rules that we remember, they all stem back to this working, okay? So stick around, watch the next few videos to see how this really works.